So some examples. The first ones are in a concept preview. It says to match each equation in column 1 with the description of the parabola that is its graph in column 2. So I'm just going to give you the equation and we're just going to talk about what would happen. So number 8, y equals x plus 2 squared plus 4. And so I want to know the vertex and if it opens up or down. So, first of all, the easiest part, does it open up or down? Up. Opens up because it's positive. Now, this is in vertex form, okay, because vertex form is y is equal to x minus h squared plus k. So, my vertex is hk if this is the scenario. So, what would my vertex be for this one? Keep in mind it has to look exactly like this or we have to change the signs when we write the vertex.
K is 4.
Okay. So if it's in this form, if it's minus h, then it would just be 2. But since this is plus 2, it needs to be minus. It's going to be negative 2. So you can think about it as h is opposite whatever the sign is given to you. K is going to always be the same sign that's given to you. All right, and then 10, y equals negative x plus 2 squared plus 4. So vertex would be what? Well, HK.
So K is H. Or no, never mind.
H is inside, K is outside.
K is 4.
Okay.
And would it be plus or would it be positive 2?
So it's got to be minus h. So if this is plus, it's got to be opposite sign. So minus 2. And then open up or down. What?
I think it's up. Oh, it's down. I think I'm down.
Opens down. Negative outside, it's down. Positive outside, it's up. All right. The instructions for the next ones say, graph each quadratic function, give the vertex, axis, okay, it means axis of symmetry, domain, range, determine the interval over which it's increasing and decreasing and all that. We're doing vertex, axis of symmetry, domain, and range. Okay, so we're doing A, B, C, and D for these questions, along with where we are going to graph it. Okay, so number 26, we have f of x equals x minus 5 squared minus 4. So, is this one going to open up or down? Let's go ahead and knock that part out first. Up. It's positive. It's positive. So this one opens up. So then part A wants the vertex. So what would my vertex be for this one?
5, negative 4.
Yep. So opposite sign, same sign. So 5, negative 4. Then it wants the axis of symmetry. Okay, so the axis of symmetry, I'm going to go back up here. It's at x is equal to h. Okay, so my axis of symmetry is what? X equals what?
5.
5. It's always got to be in the minus h plus k. So whatever your x point is for your vertex, your axis of symmetry has to be at x equals that point. Okay, your axis of symmetry is where your vertex sits. Then it wants the domain of the function, which will be easier if we graph it first. So domain and range are the next two things, but let's graph it first. So it doesn't have to be anything spectacular. So my axis of symmetry is at x equals 5. So at x equals 5, I'm going to draw a dotted line. My vertex is at 5, -4. So I'm going to go over here and go down to -4 on my axis of symmetry and put my vertex. Then I need to find another point that I can graph on either side of the axis of symmetry, okay, to find where it's going to fall in here. And then I just need those points and I can graph it. So a lot of times I pick 0. In this case, if I pick 0, that's going to be a really, really big number. So I try to pick something that's about 1 or 2 away from my axis of symmetry. So I'm going to pick 4, okay, because my axis of symmetry is at 5. So I'm going to pick 4. So you plug it in. So 4 minus 5 is -1. Squared is +1. So 1 minus 4 is -3. So then I can put a point at 4, -3. I'm 1 away from the axis here. This is 1 away. So if I go 1 away on the axis over here, it has a mirrored point. And then you can just graph it. Okay, and keep in mind it's rounded like a U, not pointed like a V. Okay, absolute value is the one that gets pointed. Parabola is rounded. So now I can do domain and range. So what would my domain be for this? Huh? Yep, -infinity to infinity, because it would eventually spread all the way out. It will take on all values. So -infinity to infinity. How about the range?
0 to infinity.
-4 to infinity. So we have to find the bottom of this, and then it goes either up or down, respectively. So this one, since it opens up, we start at wherever the vertex point is, and we go up. So -4, including to infinity. All right, 28. F of x equals -3 times x minus 2 squared plus 1. So is this one going to open up or down?
Down.
Opens down because it's negative. My vertex is where?
2.
Yep. 2, 1, because it's already in minus h plus k. And a lot of times I will write this over top so that I verify that I've done it correctly. Okay. Or to help me see it when I'm writing it. Axis of symmetry is where?
2.
Yep, x equals 2. Just keep in mind that it's a line. I emphasize that because that's a common mistake people make. Then I'm going to be looking for domain and range, but I'm going to graph it first. So my axis of symmetry is at x equals 2. So at x equals 2, I'm going to draw a dotted line. Vertex is at 2, 1. So at 2, I'm going to go up 1. So there's my vertex. It opens down. Okay, now since 0 is just 2 away, I'm going to go ahead and use 0 this time just because it's easier to work with. So I'm going to have, if I put in 0, negative 2 squared, so that's going to be 4, times negative 3, so it's negative 12, plus 1. That's still really far down, not actually on my graph, so I'm going to go ahead and do 1 instead. If it is on your graph, you can do it, or if you want to extend your graph, you can do that too. But so 1 minus 2, so it's negative 1 squared. It's 1 times negative 3, so negative 3 plus 1 is negative 2. So I've got a point at 1, negative 2. It's 1 away from the axis, so I do 1 away on the other side in the same spot. And then I just graph it. So what would my domain be?
Negative infinity to infinity.
Yep, domain's pretty much always going to be negative infinity to infinity. What about range? So what y values does this take on?
What was the axis of symmetry of the last one?
X equals 5.
Negative infinity to 1.
Yep, negative infinity to 1. And it includes 1. Alright, and then if it's not given to you in vertex form, we have to find that. So, or well, we don't necessarily have to find the form itself, but we've got to be able to find the information to be able to graph it. So 32, f of x equals 2x squared minus 4x plus 5. So I'm going to go back up to review really quick. So we said that when we need to go from one to the other, okay, to get h, we have to do minus b over 2a. And then we take f of that value to get k. So that's going to give you your vertex. Okay, so to find h, minus b over 2a. So a, b, c. Okay, these are your numbers here. Signs go with them. So negative 4. So that's going to become positive, but I'm going to write it in a second. Over 2 times a is 2. So that's going to be positive 4 over 4, which is 1. We plug in 1 to f of x to get our k value. So k is equal to f of 1. So 2 times 1 squared minus 4 times 1 plus 5. So that's 2 minus 4. Negative 2 plus 5 is 3. And then that just gives you your vertex. So your vertex is 1, 3. Okay, it goes up here. Go back. Vertex is at hk, so whatever values you get, you write those down. Your axis of symmetry is what then?
1.
X equals 1. And then we'll do domain and range in a second.
Who was that lady that was in Mrs. Marshall's class today?
I have no idea. I didn't see them. All right.
It looked like well, it wasn't a teacher here, but it, like she had like a laptop and stuff. I don't know. She might be like shadowing or something.
It's possible. Axis of symmetry, x equals 1, so dotted line.
I'm so glad that we got this.
Me too, bro. I wouldn't have made it.
I would not have taken forensics in this fractionalism.
Vertex at 1, 3.
But I feel like there are a lot of classes that I wouldn't take if like certain teachers were here.
To find the other one, now 0 is just 1 away, so that should be easy. When we plug in 0, any x terms go away, so it's at 5. So 0, 5, we have a point. 1 away on the other side. Then just connect it. So domain is
Negative infinity to infinity.
in range
32.
3 to infinity, including.
Oh no.
All right, do y'all need to see another one like this
No.
to find the h and the k? Are you okay with that? All right, then your problems are, and if we need a
Is that 1 over or 2? I can't see.
It's 1 over.
oh yeah. If we need to do a refresher tomorrow, I can do a refresher, but your problems are gonna be 9, 25, and 29 and 31.
Or, I mean, like 30 Friday, what you're gonna like add on tomorrow.